So again, the same strategy is in place. Can we write everything with the same base? So the first thing you're going to do in A is look at all your numbers. You've got a 2, an 8, and another 2. Are all three of those numbers in the same column of your powers chart? Yes, they're all in the powers of 2. So I'm going to start by changing my 8. Well, my 8 is 2 cubed. The cube root of 2, I can write that as 2 to the 1/3. What is your exponent law for multiplying powers with the same base? You add the exponents. So on this side, I'll have 3 plus 1/3. How do you add fractions? Get a common denominator. 3 is the same as 9 over 3 plus 1 over 3. Will become 10 over 3. So now we've succeeded in getting both sides as a single power with the same base. This is where I go, so using logic, this and this would have to be the same, and we're done. X has to be 10/3. This is a great example where, if before you just wanted to guess and check until you found out what was right, how long do you think it would take you to figure out, I would like to try 10/3 as my guess? Probably pretty long. Because when we guess and check, we like nice whole numbers. And so now the algebra does become very important. B. We've got the square root of 125 to the 2x plus 1 equals the cube root of 625. So again, we go to our powers chart, and are 125 and 625 ever in the same column? Yes, they're both powers of 5. So I can change 125 to 5 cubed. And I can change 625 to 5 to the 4. Now I have to use all my exponent laws and rules to make this a same power with the same base on both sides. What can I do with a square root? So I'm just going to change this. The square root is the same as a power of half. Cube root will be the same as the power of 4/3. Exponent law for a power to a power. I multiply. 2x times this becomes 3x, 3 halves. Now both sides are a single power with the same base. So this exponent here has to equal this exponent there. 3x plus 3 halves has to equal 4/3. And now you just...
Hi, sorry to interrupt.
Hello?
Did you send Joseph or...
So since those are equal, now we just have to use our fraction skills to solve for x. I can subtract 3 halves on both sides. How do I subtract fractions? I need a common denominator. So this will be 8 over 6 minus 9 over 6 3x would equal negative 1 over 6. And then to get x by itself, I'm going to need to divide both sides by 3. Dividing both sides by 3 is the same as multiplying by a third. That might be easier. When I multiply both sides by a third, I get just x equals negative 1 over 18. So some more exponent rules in that one than the first one. Try questions 9 and 10.